Oil was originally created through microorganisms capturing carbon out of the atmosphere and converting it into an oil. What we're basically doing is simulating what nature did over billions of years by taking the carbon atom off of carbon dioxide and converting it into a hydrocarbon, except we're doing it in a fraction of the amount of time. So physically, the bioreactor is two glass panels that are filled with water, and then there's a suspension of algae within there. Algae is by nature CO2 hungry. So I went to a lot of CO2 producers, and the distillery seemed to have a real appetite for this type of technology, and that's how the partnership was struck. We're capturing the CO2 from the facility and reducing their carbon footprint that way, but we're also creating more fuel independence for the distilleries or the industrial process that's burning oil, because these are effectively operating as micro refineries. They can produce and use the oil right on site. The amount of fuel generated and the amount of carbon dioxide is going to prove the commercial viability of the system, but we want to scale it up to much larger facilities. What the Shell Springboard Award did was fill a 40,000-pound capital equipment gap. Everything else was taken care of. So it was the difference between starting the project and not starting the project. I see the future of algae as a biofuel source as having, a pivotal role in the future energy supplies.